Hello, everybody. I thought I'd give you a short video lesson on IXL, the DD5, 7th grade, DD5 Make predictions using experimental probability. I haven't seen anybody that has completed this. So remember when we write probabilities, it's the probability is it's a fraction. It's what we want or the desired outcome over the total number of possibilities. So keep that in mind. We're going to write fractions. So a grocery store recently sold 20 cartons of yogurt, of which 5 were cherry flavored. So what's the total? The total is 20 cartons of yogurt and 5 the part. You could also look at this as the part over the total. So instead of want, I'm going to use the word the part, the smaller number over the total number available. And so if you look at 5 over 20, if you reduce that, there's several ways you can find the answer. How many of the next 16 cartons of yogurt sold should you expect to be cherry? So that's the question. So if you look at this and you divide by 5, in other words, you reduce your fraction, you're going to get 1/4. In other words, 1/4 of all the yogurt is cherry flavored. Is that how you spell yogurt? Yeah. So if you think about it, now you got 16 and you want to find 1/4 of 16. That's the same as 16 divided by 4, which is 4 yogurt. Would be cherry. Out of the 16, 4 of them would be cherry. So that would be the answer you would enter here. Another way to look at it is to write a proportion and solve. You can say, so let's say the part over the total and a proportion are 2 equal fractions. So in our first fraction, we have 5 out of 20 are cherry. And then we have a total of 16 and we're like, how many of those would be cherry? So then you would, instead of saying how many or a question mark, call it X, that's your variable, that's your unknown quantity. And so when you solve for X, when you find out what X is, you can do what's called cross product or cross multiply. And so that's 20 times X is 20X. And 5 times 16, 5 times 10 is 50, so that's 80. So 5 times 16, 20 times X. Notice you have no more fraction now. And 20 times what is 80? X has to be 40. And to show you, I mean, not 44, obviously. You could also divide both sides by 20. The zeros, the common zeros cancel. X is 8 divided by 2 is 4. 4 yogurt are cherry. So those are 2 ways to find out. Reduce your fraction and find the same quantity from the second part they tell you, or you can write a proportion and use cross product to solve for the unknown quantity. So that's one easy one. Now let's look at the next one. You might encounter one of these. The coffee spot recently served 42 peach scones. That's like a little, oh gosh, a scone is like a little sweet thingy, okay? And 42 other pastries. So remember, it's the part over the total. Well, you have to figure out what are the total number of scones that they sold. So you have to add the two, because it says they served 42 and 42 others. So it's not out of 42, it's on top of it all they served. So the total is actually 84. So that's, you have to find, sometimes you have to find the total. You have to read really carefully. Did it say out of? Let's see what the other one said. Of which, do you see the difference? Of which 5 were cherries. So there was total 20 yogurt. So that was easier. In this one, it just says there are 42 others. So you need to add it, yeah? So 42, so let's write another out of 84. That's half. So half of them were, my thing is acting, half of the pastry. Pastries are scones. It's like an English thing. They eat that with their tea in the afternoon. Okay, so if half of them are scones, then now they're asking how many of the next 34 pastries served should you expect to be peach scones, right? So now think of it, 34, you want half of 34. Because it's our multiplier, our ratio here is 1/2. So half of 34 is the same as 34 divided by 2, which is 17 peach scones. So that's the number we put here. Okay. And last, I have one that has a little table. So the table shows the enrollment. Again, I'm going to put our fraction up on top so we have it in front of our nose. It's the part over what you want over the total, and it's usually the part is a smaller number, the total is a larger number. That's how we keep the probability between 0 and 1, because when you divide, you're going to get a number between 0 and 1. Okay, if they're the same, then that means it's 100%, or it's the very same ratio, but usually the part is a little smaller than the total. The table shows the enrollment in a university class so far, broken down by student type. Adult education 7, graduate 2, undergraduate 9. By the way, graduate student means you already have a bachelor's degree, you're working on your master's degree. Undergraduate means you have not achieved your bachelor's degree, which is like a 4-year degree, usually 4 or 5 years, that's how long it takes, and you're still working on that. Okay, considering this data, how many of the next 12 students to enroll should you expect to be undergraduate students? So these are not the total. We have to find the total number of students that are enrolled. 7 plus 2 is 9, so that's 18. Correct? So we're going to take our total, we're going to make that 18. And we want 9 are undergraduate in our table. So that's also 1/2. 9 over 18, if you divide top and bottom by 9, you will get 1/2. Or you can use your calculator and divide, and you will see in your calculator that 0.5, which stands for 1/2. Correct? Now let's look. So this is how you find the ratio of the existing information. Now we're going to look at the next part. How many of the next 12 students to enroll should you expect to be undergraduate? So now we're going to have 12. We want half of 12. And that's 6. Because 12 divided by 2 is 6. So we know that 6 of the next 12 students are going to be probably undergraduate students, meaning they have not received their bachelor degree yet. And this is when I say probably, there's could be a graduate in there, but remember, probability is if you repeat it over and over. So sometimes you'll have like you roll a dice and you don't get the theoretical probability each time, but if you repeat something over and over, eventually the numbers will get very close to the math. This is all theoretically because we're using math. We have not done an experiment. Okay, but there you are. 6 of them will probably be undergraduate students. I want to show you one more time how to set up a proportion. So again, I say part over total. So I'm going to the given information up here. I'll start up here. So that's 9 out of 18 because it's talking about undergraduate students. Out of 18 is equal to the how many out of 12. And we're going to replace that how many with an X. That's a variable, so that means number of students, and we do the cross product. 18 times X is simply 18X. 9 times 12 is, I believe, 108. Let me try it. 9 times 12. And then divide by 18. 108 divided by 18. 6. See how we got 6? Same way. Yeah. So there's 2 different ways. Good luck to you guys. Try it over the weekend. It's already past due.